Okay, so what I want to do is I want to kind of go over this again, just in case if the video does not show up. So what we're going to do is we're going to start with the notes that I have here first. So if we're talking about kinetic energy, that is the energy of an object that is associated by the object's movement. So W net equals force, and the change in x equals mass time acceleration and change in x. That is the equation that we have for this unit. And as you can see, it has like one dimensional, and it gives us some, and then it shows how they change that equation to where we get kinetic energy, which is has times the mass times the velocity squared, which is our kinetic energy. Kinetic energy, mass and velocity of an object is a particle, so they come as a whole. So if you want to decompose the fraction, here is our equation here, and then it shows you how you distribute m over the parentheses to be able to come up with the equation that we'll be using in class. Okay, so the first one is sample problem B. So I am on page number 161. It says, this lady is from Italy. She ran 18.84 kilograms in 1.00 hours, world record at a time. If her kinetic energy was 6.94 joules, what was her mass? So what we have here is we have our change in her position, which was 18.84 kilometers, and what we did is we changed that to scientific notation. And then time is 1 hour. We changed that to seconds. Our kinetic energy is 6.94, and we're looking for what her mass was. So to be able to do that in your calculator, first thing we want to do is make sure that we have it on radian instead of degree, because there's no fraction here. So we're going to do 2 times kinetic energy, change in time squared, divided by change in position squared. So we're going to do alpha y inner to get our fraction. We're going to do 2 times 6.94 times 3.60 times 10 caret 3. Close our bracket, and we're going to square that. Then we're going to go down here. We're going to open our bracket. 1.8084 times 10 caret 4 over, close our bracket, and then we're going to square that. And we're going to go over here, and we're going to hit enter, and we get 0.55 kilograms. So if I change this back mode to scientific, because if you remember, I'm using scientific notation here, now I get 5.50 to the negative 1, and that's where they got 55 kilograms from. Okay? So then the next thing we want to do is we want to look at our practice problem number 162, question number 1. So it says, calculate the speed of 8.0 times 10 to the 4th kilogram airline, and the kinetic energy is 1.1 times 10 to the 9th joule. So what we're doing here is we have our mass, we have our kinetic energy, and now we're trying to find our velocity. So to be able to do that, still no cosine or sine. So I'm going to do second square root. Right? I'm going to do I'm going to do a fraction, because that's a fraction. Alpha y, enter to get my fraction. And I'm going to do 2. And I'm going to times that by 1.1 times 10 to the 9th power. I'm going to go down, and I'm going to do 8.0 times 10 caret 4. I'm going to go over here. I'm going to delete that, and I'm going to hit enter, and I get 1.65, which you'll round up to 1.70 times 10 to the 4th power. Question number 2 says, what is the speed of 0.145 kilogram baseball if the kinetic energy is 109 joules? So here we have our mass is 0.145 kilograms, kinetic energy is 109, and we're going to do the same formula as we did up here. So we're going to do we're going to go ahead and change and make it a square root. So second square root, we have a fraction, alpha y, enter. We're going to do open bracket 2, close bracket, open bracket, 109, close bracket, and then down, and then 0.145, that's for the kilograms, over, and enter, and we get 38.8, which I got 3.87. If I change my mode, because there's no scientific notation here, I get 38.77, which I rounded up to 38. Question number 3 says, two bullets have a mass of 3 and 6 kilograms respectively, respectively. Both are fired at a speed of 40 meters per second. Which bullet has more kinetic energy? What is the ratio of kinetic energies? So, the first thing I'm going to do is I'm going to do the kinetic energy of number 1, which means I'm going to take half of the mass and then times it by velocity 1 squared. So, on that one, I'm going to do alpha y, enter. I'm going to do 1 over 2 over, right? I'm going to open my bracket, 3.0 times 10 to the negative third power. And then I'm going to close my bracket, and I'm going to do 40. Close bracket, enter. And I get 0.6. It's supposed to be 2.4 joules. I did not square my 40. Go back up. Hit enter. And I'm supposed to square that. Enter. And there we are. There's my 2.4 joules. Sorry. Mark that on my paper so I'll remember I'm supposed to square that. Okay, so then the next one I'm going to do is I'm going to do my second mass. So I'm going to do the same thing as I did with the first one, except I'm using 6.0 instead. I'm still going to square my 40 again to get my answer. It's 44.8 joules.
Good afternoon, Gracie.
So then we have kinetic energy over kinetic energy. So I have this number divided by that one, and that is my 2 in 1.
Students interested in joining the FBLA should see Ms. Rogers or join the Google Classroom.
All right. So then we have net work on a body is equal to the change of kinetic energy. So work is kinetic energy theorem is what we're going to look at next, which is WNEX, which is net work, over the change in kinetic energy, combining all your forces to do your work of your object.
Athletes and high school car riders whose last name begin T.
Speeding.
Please make sure.
So speed increases, net force of the object is positive, work kinetic energy, and then we're going to look at problem C that is in our book. So it says the Great Pyramids of Egypt has a height of 147 meters and slides on the slope of an angle of 52 degrees with respect to the ground. Stone blocks with a mass of 1.37 times 10 to the 4th kilogram are used to construct the pyramid. Suppose that the box of the mass at rest at the top of the pyramid begins to slide down the slide. Calculate the block kinetic energy of the ground level with a coefficient of friction of 0.45. So what we're going to do here is the first thing they do is they go and they write down what their mass is, what height is, gravity, what your angle is, what your sliding friction is, and what your velocity initial is. And then we're going to go through the steps of figuring out what the equation is. So then our kinetic energy friction is mass times gravity times height, with 1 subtracting sliding friction over the tan of your angle. So if you plug this in, you should get 1.3 times 10 to the 7th joule. Now, over here is our practice problems. A hockey puck is initial speed of 8.0 meters, coasted 45 meters to stop across the ice. If the force of the friction on the puck has a magnitude of 0.12 newtons, what is the puck's mass? So what we're going to do is we're going to do our velocity initial, which is 8 meters. The velocity final is 0. Our displacement is 45. Our sliding friction is 0.12 newtons. And our angle is 180. So what you're going to do is you're going to times your sliding friction times your displacement, cosine your angle over velocity final squared, subtract by velocity initial squared. And once you do that, then you use this as your equation. So we have alpha y inner. Now I have to change my mode into degree because I do have a sign today. So over here I've got 2, and we're going to times 0.12 times 45, and then cosine 180, close, go down, 0 minus 0 squared, no, 8 over equals, and remember, on this, here, this has to be 0 squared minus 8 squared over inner, and we get 0.168, which is 0.17. Number 3 is the other one that I did. A 2.1 times 10 to the third kilogram car starts from rest at the top of the driveway, then it slopes at an angle at 20 degrees horizontal. The average friction force is 4.0 times 10 to the third impels the car motion, so the car speed at the bottom of the driveway is 3.8. What is the length of the driveway?
Students who ride bus 10, bus 3, and bus 13. Bus 10, bus 3, and bus 13. You may be dismissed at this time. Please report directly to the bus lot to board your bus. Make sure you're practicing social distancing by staying 6 feet away from others and wear your mask.
So here they have your mass, your gravity, your angle, velocity final, sliding friction, velocity initial, and your angle. And here what you're doing is you're going to do D equals 1/2 times your mass times your velocity final squared divided by your mass times your gravity, sine, and then minus your sliding friction, which is 5.1 meters. The last section talks about potential energy. Now, potential energy is energy that's stored up, okay? Energy that's associated with an object because its interaction with the environment is stored up. Gravitational potential energy depends on the height and the zero level, from a zero level. Gravitational potential energy
please report to the middle school
is an object position related to the gravitational space.
Students who ride bus 2 and students who ride bus 8. Students who ride bus 2 and students who ride bus 8. You may be dismissed at this time. Please remember to wear a mask. Wear your mask and practice social distancing.
Gravitational potential energy has to do with PEG times N times G times H. Remember your SI units are joules. Elastic potential energy, so this is gravitational, this is elastic. It's 1/2 times the spring constant times the position squared. So it had a very nice graph in a picture in here talking about a block that has a spring that's attached to the wall and how you have it, and then when you release it, and it actually shows you those information. Sample problem D.
Bus 1, bus 5, and bus 14. Students who ride bus 1, bus 5, and bus 14. You may be dismissed at this time.
Looks like this.
Again, please make sure you are practicing social distancing, wear your mask, and please report directly to the bus lot to board your bus.
Here's a sample problem. Number 1 on page 168. It says a spring force constant at 5.2 newtons, relaxing of 2.45 meters. Then the mass is attached to the end of the spring and allowed to come to rest. The vertical length of the spring is 3.5 meters. Calculate the elastic potential energy. So what you're going to do is your potential energy. Here is your change in position, which is 1.2. So you're going to take 1/2 times your kinetic energy and then your x squared to get that number. This is number 2, and this is number 3. I hope you have a great day.